integration by parts. So for our first one, we have the integral of x e to the 6x dx. And this is about as simple of an integration by parts problem as you can have. And we have two functions clearly that are multiplied times each other. We have x and e to the 6x. And we can see here that a substitution wouldn't really work because even if we set u equals 6x, our derivative, our du, 6, would not get rid of this x, and we'd be stuck in a conundrum using x and u. So this is where you want to use integration by parts. And remember that when doing integration by parts, remember the acronym LIATE. So what that tells you is the order in which you would want to call something u or dv. Towards this side, you want to call something u. Towards this side, you want to call something dv. And remember that these are logs, inverse trig, algebraic, trig, and exponential functions, where algebraic just means polynomials, rational things. So here we have an algebraic function, x. Remember that if you have something like the integral of a log or an inverse trig function, the dx could be considered 1 times dx, and 1 is just an algebraic function too. So just the dx could be considered an algebraic function. So our but we also have an exponential function, and exponential functions you always want to call dv. Sometimes when you have trig and exponential in the same function, it doesn't really matter, but clearly in this case we want e to the 6x to be our dv. So if we use integration by parts, we get that u equals x, dv equals e to the 6x dx. So when we do fill out our integration by parts chart, du is just dx, and v is e to the 6x over 6. So remember that when you integrate an e to a given power, if the derivative of that power is a constant, you're just dividing by that. It's the inverse of chain rule, you can think of it like that. Remember that also is true for any function. If your innermost function is just a constant times x, you can just treat everything as if it was just x and divide by that number at the end. So in using our integration by parts formula, we get 1/6 x e to the 6x when we do u times v. And we do minus the integral of v du. So this, I'm going to put the 1/6 in front, and we're just going to get the integral of e to the 6x dx. Well, that's really simple because we just did it here. So everything's going to work out nicely. I have a 1/6 here and a 1/6 here, so I can factor that out. As well as, well, actually let me leave the factor until the end. So we have 1/6 x e to the 6x minus 1/6 times this integral, which is here. And we have 1/6 times the 1/6 from this would give us 1/36 e to the 6x. So now what we can factor out is an e to the 6 and e to the 6x and a 1/6. And what we're left with in the first term is just x. In the second term we have a 1/6 still there because we factored out 1/6 and it was 1/36. Finally plus c. And that's how we do our integration by parts for this function.